Hello, my dear boys. All of you are welcome to my online class. Hope all of you are well by the grace of our Almighty. Okay, and now today I will discuss on also chapter 7. The name of our chapter is Waves and Sound, and today's topic is we will try to solve a creative question. Okay, so our class is on how to solve creative questions. So let's the creative question first. Okay, our creative question is here wave of sound from a specific source in air, and the given picture of this sound source. Okay, here we know that sound is a longitudinal wave. Okay, and the characteristic of one of the most important characteristics of a sound wave is it uh, consists contraction and expansion. It consists uh, expansion and contraction, expansion and contraction and expansion. Okay, so the figure shows a specific the wave figure of sound source. Okay, here the velocity of sound is in air is given 347 meter per second, and in water is 1474.75 meter per second. Our question number A is what is wave? What is wave? This is our knowledge based question, and the comprehension based question B is write down two difference between transverse and longitudinal wave. We know that we have two types of wave. One is transverse wave and another is longitudinal wave. Okay, and question number C is determine the temperature of air. Determine the temperature of air. Okay, and the question number D is what will be the sense of wavelength of sound in water in compare with air? Explain with mathematical logic. Okay, again say that question number A is what is wave. Question number B is write down two difference between transverse and longitudinal wave. Question number C is determine the temperature of air. Okay, and the question number B is what will be the change of wavelength of sound in water in compare with air? Explain with mathematical logic. Okay, so let's see the solution. A. What is wave? Wave is a process of transferring energy from one place to another through a medium. Where the particles of medium, the particles of medium can oscillate about their position but are not displaced permanently from there. Okay, this is the answer for question number A. The question was, what is wave? So the answer is, wave is a process of transferring energy from one place to another through a medium where the particle of medium can oscillate about their position but are not displaced permanently from there. Okay, so we know that the main characteristics of the wave is transferring energy from one place to another, and we know that the particle is not exchanged their places, they are only oscillating about their position. Okay, so this is our wave. Okay, so this is also very important type of knowledge based question. Now our comprehension based question. The question is difference, write down two difference between transverse and longitudinal wave. To answering this question, you can answer this question by in a box, or you can answer this question with logic. Okay, so the distinguish between longitudinal and transverse wave. So first of all, transverse wave and longitudinal. Wave. Number one. This type of wave is formed by crest and trough. Wave is formed by crust and trough. Okay, and for longitudinal wave, number one is this type of wave is formed by contraction and expansion. This type of wave is formed by contraction and expansion. Here I am drawing the figure of transverse wave and longitudinal wave. This is not our answer. This is only for understanding the answers. Okay. So this is our transverse wave. Here this is called crest and this is called trough. Okay. Crest, trough. Crest, trough. Okay. And here the figure for longitudinal wave. This is expansion, this is contraction. Expansion, contraction. Okay. Okay. So the number 2 is direction of crust and trough is perpendicular to the direction of propagation. Here, direction of contraction and expansion is parallel to direction of propagation. Okay, here the distinguish between transverse wave and longitudinal wave is direction of crust and trough is perpendicular to the direction of propagation. Here, direction of contraction and expansion is parallel to direction of propagation. Okay, here this is our transverse wave and this is our longitudinal wave. The example of transverse wave is light wave, and wave in a pond is transverse wave, but the example of longitudinal wave is sound wave. Okay, the wave of string is also a transverse wave. Okay, yes, any type of sound wave is longitudinal wave. Okay, so this is our distinguish between transverse wave and longitudinal wave. Okay, now the answer for question number C. Here we need to determine the temperature of air. Here we have given the velocity of air is 347 meter per second given in our step. Okay, so we know the speed of sound at 0 degrees Celsius temperature is 330 meter per second. So here T1 equal to 0 degrees Celsius or 273 Kelvin, and V1 330 meter per second. And we have given V2 equal to 347 meter per second, velocity of air at a certain temperature, and we need to determine this certain temperature T2 equal to what? We know we know the relation between velocity and temperature is V is proportional to square root of temperature. So we can write V1 by V2 equal to root of T1 by T2, or T2 by T1 equal to V2 by V1 square. Okay, then T2 equal to V2 by V1 whole square into T1. Putting the value of this velocity and temperature, we can write 347 here, 300 into here whole square, and T1 is 273. Okay, calculating, we get here 347 भाग 300 square into 273. So okay, so here the value of V1 is 330. So calculating 347 divided by 330 into whole square into 273. So we will get T2 equal to 301.85 Kelvin. So or T2 equal to 301.85 minus 273 degrees Celsius, here minus 273, so we get 28.85 degrees Celsius. So the temperature of the air is 28.85 degrees Celsius. So we can write, okay, so we can write the temperature of air, temperature of air is 28.85 degree Celsius. Okay, so this is our answer for question number C. Now we will calculate the question number D. The question number D says that what will be the change of wavelength of sound in water in compare with air? Explain with mathematical logic. Okay, so here given that velocity of air VA equal to 347 meter per second, and velocity of sound in air, sound in water VW equal to 1474.75 meter per second. Okay, So VW by VA equal to 1474.75 divided by 347 equal to, we can write 1474.75 by 347. So it is 4.25. So we can write our very popular equation V equal to F lambda. Here the F is frequency. Here and in from our mathematical problem, from our stream, we say that our frequency is same. So we can write V A equal to F into lambda A, equation 1. And another V water equal to F into lambda water, equation 2. And divided these two equations, we can write VA by VW equal to lambda A by lambda W. So our lambda W is lambda W is VA by V water into V water or VA into lambda A. So we can write lambda water equal to V answer. V water, velocity of sound in water 147. Okay, we know that VW by VA is 4.25, so you can write 4.25 into lambda A. So in our discussion, we can say that the velocity wavelength of sound in water is wavelength of sound in water is 4.25 times greater than the wavelength of lambda H. Okay, here lambda W is the wavelength of sound in water, and lambda A is for the wavelength of sound in air. Okay, so from this relation, we can say that the wavelength of sound in water is 4.25 times of wavelength of sound in air. Okay, so this is our discussion. So we can write wavelength of sound in water is 4.25 times wavelength of sound in air. Okay, so this is our answer for our given creative question. Okay, try to do more creative question, try to practice more creative question on this chapter, because this chapter is very important for SSC exam. Okay, in our next class we will discuss about our new chapter. So until then, uh, thank you.